So find the current through the thevenins theorem. By using thevenins theorem, find the current through the 10 ohm resistor by using thevenins theorem. Thevenins theorem. So um, there are three steps are involved. First, finding VThevenins. Second, finding RThevenins. Third, merging RThevenins and VThevenins to 10 ohm resistor. So nothing but VThevenins and RThevenins in series, VThevenins and RThevenins in series, and these two are connected between between a resistor or a load where we want to find the current. So this is the final stage. First we should find VThevenins, second we should find RThevenins, third we should find third we should connect VThevenins and RThevenins in series, and for this series combination we should connect the load resistor, whatever the load resistor is there, that is. So let us find VThevenins first of all. This is the VThevenins we should find. So to find the VThevenins, we should open 10 ohm resistor like this. So let us redraw the circuit, and that will be like this. This terminal must be open. Where we want to find the current, there we should open the terminals in the Thevenin's theorem. By using Norton theorem, we should short circuit the terminals. That is the difference. Here, from this, we should find the VThevenins. So this is terminal. Let us take A, and this is B, or this is positive or negative, whatever you take. Now, as I discussed earlier, like that. So we should take a path. We should take a path from A to B. From A to B, we should take a direction, nothing but one path. And in that path, what are the resistors are there? This 15 ohm resistor is there. This 8 ohm resistor is there. This is 8 ohm resistor. This is 2 ohm resistor. And this is a 5 ohm resistor is available. So this is 5 ohms here I wrote. This 15 ohms I wrote here. This 10 ohms open circuited because there we should find the current, and 8 ohms I wrote here, and 2 ohms I wrote here. This is 10 volts and this 20 volts. Now if you want to find the voltage across the 15 ohms resistor, we should find the current through that one. Then only we can find the VThevenins. VThevenins is equal to voltage across the 15 ohm resistor plus voltage across the 8 ohm resistor. In that path only these two resistors are available. So if you find the voltage across those two resistors, that will be the voltage VThevenins. So now let us find the current through in this loop. This loop current is equal to, from loop 1, current is equal to I is equal to voltage. Voltage is 20, and in that loop 15 ohm plus 5 ohms, 20 ohms. So total is current is 1 amp. And in the loop 2 is nothing but this one in this direction. Loop 2, current I is equal to V. V is 10 volts. And resistance is how much? 8 plus 2. 8 plus 2 is 10, which is equal to 1 amp. 1 amp. Now, V Thevenins is equal to voltage across the 15 ohms. Voltage across the 15 ohms is, so now the most important point is, so the current path is in this direction, downward. In this 15 ohm resistance also same direction. Currents are assumed direction and actual current flow direction both are same. So that we should take positive, and 15 ones are voltage across the 15 ohm resistor is IR. I is nothing but 1 amp into R is nothing but 15. Next, voltage across the 8 ohm resistor. So look at this one. This is assumed path, upward direction, but current is always positive to negative. This is downward direction. Both are opposite. So that whenever current and assumed directions are opposite, then we should take minus here. Minus. And voltage across the 8 ohm resistor is IR, I is how much? 1 amp. 1
1
amp and R is nothing but 8 ohms. Now 15 minus 8 equal to how much? 15 minus 8? This is 7. 15 minus is 7 volts. V Thevenin's is how much? 7 volts. Now let us find R Thevenin's. While finding the R Thevenin's, whatever the voltage sources are there, those sources. So let us find RThevenins. While finding the RThevenins, whatever the voltage sources are there, that should be replaced by the internal resistance. So internal resistance of voltage source is 0. So that will be treated as short circuit. That will be represented in this manner. Whenever current sources are there, current source will be short circuited. Sorry, current source internal impedance is infinity. So that will act as a open circuit, that is represented as like this. So now in this case, in this given problem, only 20 volts and 15 volt only voltage sources are there. So those voltage sources should be replaced with short circuit. So that will be like this. That will be short circuited, and a resistor is there, another resistor, and we should find the R Thevenin between these two terminals. Again resistor, and this another resistor, and this is short circuited. So this is 2 and this is 8 and this is 15 and this is 5. Here we should find RThevenin by looking into this. So this 5 ohms and 15 ohms are parallel, because if we take any current path, current will be divides. So in this direction also, if you take a current path, these two will divide, so that 15 and 5 are parallel. So that equivalent is 5 into 15 by 15 plus 5,
5 plus
5 ones are 5 fours. 15 by 4 is the R Thevenins. Sorry, this combination of these two. Now, these two are in parallel. 8 and 2 are parallel. So, which is equal to 8 into 2 by
2 by 10.
2 ones are 2 fives. 8 by 5.
5.
Now, R equivalent is equal to, these two are in series now. So, total R Thevenin is equal to, these two are in series because these are connected in parallel. I drawn only one diagram. So, this is equivalent circuit will be like this. This is R Thevenin. Here, 15, 5 and 15, and here 8 and 4 parallel like this. If we add these two, 15 by 4 plus 8 by 5. This is the R Thevenin. This is R Thevenin. So the simplification of this 15 by 4, nothing but the sum of these product. This is the parallel of this one. It becomes 15 by 4, and the 8 two are in parallel. The combination will be 8 by 4. These two are in series. So that if I add that one, we will get 107 by 20. This is the LCM. 107 by 20 is the R Thevenin. Now, final step is step 3. In the step 3, V Thevenins and R Thevenins connected in series between the AB terminals. Whatever the resistor are there, that should be connected in series with the given. Because this is R Thevenins and V Thevenins. So V Thevenins is equal to how much? V Thevenins is equal to 7 volts. R Thevenins is equal to 107 by 20.
107 by
So
20.
now current through 10 ohms is equal to, in this direction, current through 10 ohms is equal to, according to the KVL, total voltage V Thevenin's how much? 7 volts by R Thevenin's. R Thevenin's is nothing but 10 plus 107 by 20. 10 plus 107 by 20. So this 107.220 will be written as 5.35. So 7 by 10 plus 15, 15.35 amps. So you may have calculators. By using calculus, if you find this one, you will get the answer as current to the 10 ohms is equal to 0. So look at this one, 7 1s are 7 2s are. So that less than, we will get less than 0 0.1 by 2, nothing but 0.46 amps. This is the answer which is asking.